Okay, looking at Organic Skills Training Exercise 5, we have a synthesis question in this question 1. So in this case, we have an halogenous alkane that you can see over here is converted to an secondary amine. Okay, so if you recall your organic chem reaction mechanism, your halogenous alkane can be converted to an amine via nucleophilic sub. Now, importantly, you will also notice that there's an additional alcohol functional group over here. So in this case, they mentioned that there's an intermediate compound that gives a positive test with cold alkaline KMnO4. This will indicate that this must be an alkene functional group. Okay, so only alkene will give a positive test with cold alkaline KMnO4. So you can almost imagine that A will have to undergo elimination. Okay, so in this case, let's think of consideration. If we think backwards like what we did, the amine will have to come from a halogenous alkane. So if I think of it this way, alright, my halogenous alkane replaced with amine via nucleophilic sub, and then my alcohol remains as an alcohol functional group. Then, because we said that we need to go through an alkene functional group, so the only logical way is to have an alkene. So the first reaction will be an elimination reaction. In this case, the halogenous alkane, alright, the Cl and the hydrogen on the adjacent carbon will be removed, and this reaction we can basically do it with alcoholic KOH or ethanoic KOH heat. Alright. Now, in this case, we need to add the OH and the Br onto the alkene CC double bond. This is an electrophilic, not substitution reaction, but rather addition reaction. Okay, involving an alkene. Okay, involving alkene. So you need your equals bromine. Okay, so just a quick recap on your concepts here. In this case, there are 2 hydrogens on this terminal carbon. There's only 1 hydrogen on this carbon. So based on your Markovnikov rule, your bromine electrophile will be added to the carbon with more H, and therefore generate a carbocation on this carbon here. Okay, this carbon here, hydrogen yellow, and that's why your water, which is from the aqueous state, can form your alcohol. And last but not least, the last step involves your nucleophilic subreaction. Your Br is replaced with an amine, okay, to form a tertiary amine. In this case, the amine that we're looking at, if you to look at the pattern recognition, alright, we will not use ammonia, we will use CH3 and H2. Okay, so over here I try to mirror the conditions as that of ammonia. We want a mono substitution to occur, so we use excess corn, amine, dissolved in ethanol, and heat in silk tube. Okay, so it's very similar to your ammonia replacing a Br. Okay, if not, that's it for your question 1, 3-step process. Alright, and I followed the clue given that it involved an intermediate which involved an alkene functional group.